Okay, so here we have a pheromone, and it gives us the formula. It's C19H38O. So it's a fairly complicated molecule, 19 carbons bonded together with one oxygen, sharing electrons, and the hydrogens are going to be on the outside, so they only have one bond each. We could try to draw a Lewis structure for that. It would probably be dozens of Lewis structures that we could possibly draw that would have that formula. So if we wanted to know exactly how the carbons and oxygen and hydrogens connect together and how they're sharing electrons, we would need more information about exactly what the structure is. But here we're just given the formula, and it says normally the amount of this pheromone secreted by a female insect is about 1.0 times 10 to the negative 12th grams. So we could call that maybe one dose secreted by the female. How many molecules does this quantity contain? So a molecule is a unit, and this is a conversion because we want to convert this quantity. We want to know how much in that exact quantity or in that exact dose is there. But rather than knowing how much of it in grams is there, we want to know how much of it in molecules is there. How many molecules are there? So we're asking how many molecules are equal to this quantity in grams. Oops, that's a 12. So just like any conversion, we need relationships. And we know in every example we've seen when we're converting from a laboratory scale quantity or unit, which would be measured in grams, to something that is super tiny like atoms or molecules, we need to use Avogadro's number at some point. So that's one relationship we'll need. In this case, the tiny substances we're working with are molecules. So Avogadro's number of molecules will be equal to 1 mole of molecules. Avogadro's number is just a number that means that it's just a mole is just a word that means that specific number of items. So a mole is always equal to Avogadro's number of items. And then we want to get grams involved because that's the unit we're starting with. So if we can get to molecules knowing the moles, and what we have is grams, we need to be able to get to moles from grams. So what is the relationship between grams and moles? That's the molar mass, right? We just calculated that in the last example. If we don't have given information to calculate it, we can always use the periodic table. So if you want molar mass, you either need to know the formula, or you need to be given some information about grams and some information about moles, or that you can convert to grams or moles to divide and get the molar mass. So in this case, we would use the formula to get the molar mass. So I would take 19 carbons, 19 times the mass on the periodic table of carbon, plus 38 hydrogens, 38 times the mass of hydrogen, plus 1 oxygen, and add that together. And I get 282.49. So that's the number of grams. So when I add the masses for elements on the periodic table, that's the number of grams equal to 1 mole. That's what molar mass is. It means if I had a mole of this substance, or Avogadro's number of items of this thing, that's how many grams it would weigh. Right, so now I've got the relationships I need. So I want grams to cancel, so I'll do 282.49 grams equals 1 mole. Then I want to cancel the moles and get molecules, so I'll say 1 mole is equal to 6.022 times 10 to the 23rd molecules. So grams cancel, moles cancel. I've got the unit I wanted. So then I just need to plug in whatever I have on top, 1 times 10 to the minus 12, or 1e negative 12, divided by the 282.49 times 6.022 E23, and I get 2. Fortunately, I'm limited to 2 sig figs here by the 1.0, so I have just 2.1 times 10 to the 9th molecules of the pheromone. So just over 2 billion molecules. And that's a nice illustration because 1.0 times 10 to the negative 12 grams is a super, super tiny amount. You think about trying to weigh that on these scales, you wouldn't be able to because the scales we have only go to 4 decimal places. But this is 12 decimal places out from 1. So even a very, very small amount of mass still has a couple billion molecules in it. So it's really how light or small, or how small in weight these molecules actually are. And this is a pretty big molecule too. It's got a lot of atoms involved in it.